Hello students, today I have come with a very important rule called Cramer's rule. This rule is very important for the physics honors student and PG students because there are a large number of problems in electronics and current electricity which are very easily solved by applying Cramer's rule. So at present I will explain what is Cramer's rule, and in the next lecture I will explain the proof of Cramer's rule. So let us start to explain what is Cramer's rule. To explain Cramer's rule, suppose that there are three equations. These are linear equations and simultaneous equations. a1x plus a2y plus a3z, a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, a3x plus b3y plus c3z is equal to d3. In these three equations, a1, b1, c1, d1, a2, b2, c2, d2, a3, b3, c3, d3 all are constants, and x, y, z are variables. Now suppose that we have to find the value of x, y, z in terms of these constants a1, a2, a3, b1, b2, b3, c1, c2, c3 and d1, d2, d3. So Cramer's rule states that first of all we should make these three equations in matrix form. The matrix form of these three equations are a1, b1, c1, a2, b2, c2, a3, b3, c3, x, y, z is equal to d1, d2, d3. When we will explore this matrix, then we will get these three equations like this: a1x plus b1y plus c1z is equal to d1, and so on for the other terms. So when we have to find x, then this is the x is in the first row of this column. So d1, d2, d3, this will be put here in place of a1, a2, a3. That is, this column a1, a2, a3 will be replaced by d1, d2, d3. Then we will get x is equal to d1, d2, d3, b1, b2, b3, c1, c2, c3 divided by the this determinant a1, a2, a3, b1, b2, b3, c1, c2, c3 is the determinant. So the value of x will be equal to the determinant of d1, d2, d3, b1, b2, b3, c1, c2, c3 divided by the determinant of a1, a2, a3, b1, b2, b3, c1, c2, c3. Now suppose that we have to find the value of y. Then since y is here in second row, so d1, d2, d3 will replace b1, b2, b3. That is, we will get a new determinant a1, a2, a3, d1, d2, d3, c1, c2, c3 divided by this determinant a1, a2, a3, b1, b2, b3 and c1, c2, c3. Similarly, when I have to determine z, then since z is in the third row, therefore this column matrix will replace the third column c1, c2, c3. Then we get Z is equal to A1, A2, A3, B1, B2, B3, D1, D2, D3 divided by the original determinant. In this way, if we have a large number of variables having a large number of linear equations, then by applying this Cramer's rule very easily and directly we can find the value of variables. This is the importance of this Cramer's rule. Now in the next lecture we will prove how this Cramer's rule behaves like this. How this Cramer's rule will be deduced to show these results. Thank you. I think that this Cramer's rule will be very advantageous and beneficial for the honors student and PG students. So you please share this rule among the honors students and physics honors and physics PG students. Thank you.